Do I have your attention? Good. I want to talk about how matter communicates. First on a quantum scale, but then opening up a big mess of philosophical questions that have to do with information on all scales. So first, matter. Matter is any of this stuff. I mean, I'm counting antimatter here because it's basically the same as matter, just with opposite charge. Technically, I could also include all the stuff over here on the right side of this chart. It's kind of an arbitrary choice what to call matter and what not to call matter. It's a piece of vocabulary. Most importantly, for all of the physics around us in everyday life, is to focus on just these four quanta in the chart. They're the ones that are in ordinary matter, whereas the rest are a little bit less common in nature. And if we want to think about how matter communicates, what usually is involved is these quanta interacting with each other by exchanging these quanta here. In a way, these force-carrying quanta are the tools for communication on a microscopic scale. To see how this works, think back to the simplified model of an atom that we discussed a while back. It takes a kind of communication between all the particles involved in order to create this structure. You may have learned at some point that the opposite electric charge between the protons and electrons makes them attract. And you also may have learned that the nucleus is held together by something called the strong force, or sometimes called the nuclear force, or sometimes called the strong nuclear force. Those forces, along with a third force called the weak force, are represented in the standard model of particle physics. Anytime that quanta are interacting via the strong force, they're exchanging gluons. Anytime that quanta are interacting via electromagnetism, that is, interacting because of their electric charge, they're exchanging photons. And then there's the weak force. It's the weird one, with three separate force quanta. You almost never hear much about it because it's genuinely strange and hard to explain. Usually people don't try. And sorry, that's also the approach I'm going to take right now. Just like I sneakily erased the weird thing called the Higgs boson from this picture, because I didn't feel like talking about it. And also, like, I haven't commented on a big problem with this whole scheme, which is that gravity isn't even included despite being classified as the fourth fundamental force. Right. Point is, there's a lot I'm not explaining, and you should know that. But what I do want to convey here is that the standard model of particle physics, representing our understanding of what exists on a quantum scale, recasts how we should think about forces or interaction. If we think about an atom as an assemblage of up quarks, down quarks, and electrons, then we might add in some gestural scribbles to indicate the exchanges of quanta that are taking place in order to keep the atom together. Up and down quarks are exchanging gluons, which I've drawn with a pinkish color. This accounts for the strong force binding them together into protons and neutrons. And then quarks and electrons are exchanging photons, which I've indicated with a greenish-bluish scribble. This accounts for the fact that the electrons feel pulled towards the nucleus and don't go flying off. And really, the picture should be a lot more complicated, since protons and neutrons are exchanging gluons with each other, and all the quarks are constantly exchanging photons with each other, and the electrons are exchanging photons with each other also, and they're all exchanging photons with whatever other atoms are around. And never mind that I haven't added anything in here to address how the weak force is involved, which it is. But anyway, generally speaking, once you get outside the nucleus of an atom, the only thing that's really being exchanged much is photons. So while all three of these forces play a role in the structure and behavior of matter, as soon as you start thinking about anything bigger than the nuclei of atoms, or start thinking about sensing and communication of matter on a macro scale, electromagnetism is where it's at. Exchanges of photons between atoms are the main way that, well, basically the main way that anything happens. Like earlier in this series of videos when we talked about how nothing ever touches, because what's really happening is that the electrons in the atoms of one material are repelling the electrons in the atoms of the other. That repulsion is communicated by the exchange of photons. And as I jiggle around a bunch of beans in a cardboard box, they bounce off one another. And what's really happening there is that the electrons in one bean are repelling electrons in another by exchanging photons. And the same kind of thing happening microscopically, with molecules of air bouncing off of each other, is what we mean when we talk about sound. So in that sense, sound involves the exchange of photons too. So do smell and taste, seeing as how those senses involve chemical interactions, and chemical interactions are all about atoms attracting and repelling each other through electromagnetic forces, meaning through the exchange of photons. Which is weird if you think about it. I mean, I've previously described photons as the quanta of light, that is, as extremely tiny bits of light. Obviously, light is involved in the sensation of vision. So, am I also saying that light is involved in touch and hearing and taste and smell? Well, yeah, kind of I am. But the light in most of these cases isn't something you could ever see. And I don't mean that in the sense that, like, some other organism or a different kind of sensor can see the light. That happens too. But no, I mean because in the chaotically non-narrative quantum process of communication, photons don't always stick around long enough to be capable of triggering the kind of sensory event that we mean when we talk about seeing or sensing, in any sense. Confusingly, the terms real and virtual are used to distinguish between the different ways that quanta-like photons can manifest. It's not a great analogy, but to get a vague idea of what this means, think about when you're running water into a pot or a tub. Near where the water flows into the pot, the ripples created are chaotic and ephemeral. Only further away from the input stream can you start to notice patterns of regular ripples that travel across to the other side. By analogy, the messy and short-lived ripples near the input stream are like virtual photons. The ripples that radiate out to the other side of the pot are like the so-called real photons. In real-world materials, both real and virtual photons are always being produced and absorbed. Like, for example, here's an infrared or thermal photograph of a mug full of hot water. The mug is glowing with infrared light, which is invisible to the human eye, but which can be detected with the right sensor. The infrared light consists of so-called real photons, which radiate into the world like the ripples in the pot of water that radiate away from where the water is being added. The infrared light here is a result of the heat in the mug. But what exactly is that heat? It's the motion of many molecules bumping around in the mug itself, a lot like my beans in the cardboard box. Those molecules bounce off each other by exchanging virtual photons. The communication of matter via virtual photons happens at the same time as a kind of communication via real photons that can in fact tell us something, like here where my camera shows clearly the profile of the mug, the heat reflected off the table, and so forth. Microscopically, virtual photons leave their mark on the world by establishing structures, mediating and constraining changes in ordinary matter. But also, because so-called real photons are constantly produced as matter interacts microscopically, everything in the universe always glows. Some things are hot enough to glow in visible light, but other things glow in infrared light, or even in the radio wavelengths of the electromagnetic spectrum, and so on. This means that even the darkest night, or the darkest, deepest hole underground, or the most remote area of empty outer space, all of those places are best considered, on a physical level, to be blindingly, absurdly bright with light. Just maybe not always the kind of light the human eye can see. Whether you notice it or not, matter is always communicating through space, on macroscopic scales as well as microscopic scales. And so are we. It's within this overwhelming chaos of an environment of light that we seek to make and send messages to one another, like the messages communicated between our house and the world through the antennas on the roof. In this strange 2020 world, the roof is an interface to the world, an interface that we need in order to participate in online communications that define everyday life, a wholly different kind of virtuality than what I mean when I talk about virtual photons. Do I have your attention again? Well, good, okay. Quick recap. On a quantum scale, matter communicates by means of exchanging force quanta, and photons are by far the most important force quanta to understand if you want to make sense of material interactions. Every sensory experience we have is mediated by the exchange of photons, be they so-called virtual photons or real photons. And the communication systems we employ as humans can be understood physically as a manipulation of the electromagnetic environment, the light environment all around us. That is, a manipulation of photons, their creation, their absorption, their properties, their trajectories through space. Change of subject! Ha. The big crop field on our farm has been completely harvested for the final time. And I've been spending my days lately walking over it and planning our environmental restoration project. A big part of this is figuring out good places to mow paths through the future prairie plants, which we will then also use as fire breaks for controlled burns, restoring fire to the ecological cycle of this land. When we first moved here, a neighbor down the road showed me a satellite image of her own field, of a similar size, into which she had mowed paths that were in the shape of a peace sign. Just between us, I thought it was a little bit tacky. But in planning our prairie layout, I did briefly think about what sign or symbol I could mow into our field to be viewed from space. Maybe something really geeky and obscure, like an H-bar, which is a symbol used in quantum physics. But that whole idea felt worse than tacky, and not just because of the creepy assumption of our constant surveillance from space. It also felt symbolic and disrespectful relative to the human history of this place. This part of the world is marked by ancient remnants from the mound-building cultures that lived here some 3,000 years ago. Those civilizations built earthen forms representing animals for unknown reasons, and conveying signs and information with unknown meanings. Unknown, but still somehow important. At least I think they're important. Who knows if this field may previously have been filled with symbols, broadcasting messages to the empty sky, and erased in the same acts that repurposed the land for contemporary agriculture, and made such an environmental mess that we're going to be working hard for years and years and years to undo it. As usual, I'm overthinking. I mean, it's some paths in a field, Kathryn. But it does have me stuck on some philosophical questions about signals and communication. Communication usually implies the exchange of information. But what is the physical basis of information? Do quanta like photons always intrinsically carry information? Is information exchanged when virtual photons mediate the interactions between electrons? Or only when so-called real photons carry an imprint, like the imprint of a pattern in a field, out to space? Does information require intent? Is there only information when I've made a mark on the world that someone finds to be meaningful? Or is my constant and invisible imprint on the environment, not just the ecosystem kind of environment, but the light environment, is that a type of information too? Any intentional message, the sending of a signal, must have a narrative component. Should I wish to send you a message, an intentional message, I have to be able to imprint my message in some way on the physical properties of a system, like on a set of radio light photons or a set of visible light photons. And then that imprinted signal needs to be able to be transmitted and then received and interpreted. Because individual quanta, like individual photons, can have distinctly non-narrative behavior, there are lots of open questions in physics about exactly how they can and cannot exchange information. That is, how they can and cannot convey messages. In particular, in the last video we talked about entanglement. Entanglement may be a sort of a spooky action at a distance, but you can't use it to send a message. And that's exactly because of its non-narrative character. After the fact, the correlations exhibited in quantum entanglement may show that the properties of distant quanta had a relationship. But any intervention you might make to know or control the story would break the relationship. In other words, complementarity, or quantum uncertainty, operates at a level beyond our ability to manipulate. Even though there is a strange way that entangled photons seem to be sharing a secret, there's no way that I can use entangled photons to tell you a secret. And honestly, if we really need to exchange secrets, we don't need entanglement. Old-fashioned radio will do just fine, we just need a good code. Some way to obscure the meaning in a perfectly macroscopic signaling system that involves so many photons that we can ignore quantum effects and work entirely in the realm of narrative and predictable physics. Narrative predictable physics manipulated with intent, labeled with meaning. We can send messages into the world intentionally through our manipulation of signals, usually electromagnetic signals. But how should we think about the information, if it counts as information, that is broadcast into the world by objects without intent, and potentially without obvious meaning? My choice to put on lipstick before virtual meetings is a way that I intentionally manipulate light, the light that reflects off of my face and is encoded and sent to my collaborators via webcam, laptop, satellite, and so on. The webcam doesn't record the infrared light unintentionally emitted by my face. I can't put on any makeup that makes my nose less cold, and thus less prominent a feature in my infrared visage. Does the intentional pinkness of my lipstick count as a message when the unintentional coldness of my nose doesn't? Both are altering light in the environment. I don't have any resolution to any of these questions, and really physics doesn't. Surprisingly few physicists have thought about these questions, and I think it's a place where physics could benefit from learning from art, where the questions are as old as the impulse to create. Is the meaning of a work in the intention behind a mark? Is it in the fact of the mark itself, the fact that the mark exists, that it carries the potential for interpretation or the potential to foment change? Or is the meaning in the significance that the mark takes on to a viewer in a given context? P, here, for Papa, who would have turned 81 this year and won't get to see what we do with the field, but who would have loved it. We miss you.